Now if I rotate it this way, you can see the entire picture of the cone or the strobilus. Um, this is a longitudinal section of a strobilus, of a cone. Okay, these are the leaves, okay, or the, what do we call them? They are known as the sporophylls or the fertile leaves. Okay, fertile leaves is because they carry the spores. Now on top of the leaf, do you see on the inner side you are seeing some bulbs there, there, this one, this rounded structure. This is the magnified this is the magnified sporangium. Okay, now this sporangium, okay, these and the other side also, these sporangiums. Now look at the magnified one. You can see that there is one jacket. Okay, there is a layer of jacket. These are the cells of the jacket. Then you have one innermost tapetum layer, and then inside are these cells. Okay, spore mother cell is one cell with a nucleus, all right, with cytoplasm and nucleus. Okay, these cells, these are known as the spore mother cells. Why they are mother? Because they will be the one who will produce the spores. Okay, these spore mother cell, they will undergo meiosis, and they will produce how many? 4 spores. All right. Now, so I think just to remind you, mitosis, from one cell we get 2, right? And these are diploid, no, twice n. But from meiosis, from one cell you will get 4, isn't it? And all these are n. All right. Okay, so the spores will become n, or haploid. Okay, so let's continue. Okay, the sporangia, it occurs singly on the adaxial surface of the leaves, known as sporophyll or fertile leaves. Remember that small bulb? That is your sporangia. Okay. Now those leaves, those sporophylls, they form a protective covering. Remember it was like this, no? So these leaves, they are forming a protective covering around these sporangiums. Okay. So these sporophylls will be grouped together and it will form a strobilus, okay, or a cone. Okay, so all those leaves, no, this leaf with a sporangium, this leaf with a sporangium, similarly the other side, no, it's so difficult to draw on this. They will clump together and they will form a cone or a strobilus. So from the image is very much clear, no, you can understand. Okay, let's continue. The sporophyll of such strobili are different from the vegetative leaves. Okay, so those are the fertile leaves. So those sporophylls are the fertile leaves. They are different from the vegetative leaf or those ordinary scale leaves we saw in their size, in their shape, and in their color. Okay. These type of strobili may occur on the leafy stem or may be erected on lateral branches having very small scale like leaves. Okay, just remember from there only. Remember there was this, you could find it like this directly, or that other one, it was like this, no? Remember those were the leaves, ordinary leaves. Okay, you just look at the sporophyte diagram, you will understand. Okay, in certain species of Lycopodium, for example Salago, the sporophyll are similar in looks to the ordinary leaves. Okay, so in this species you cannot know who is ordinary and who is fertile because they look alike. So here it is completely random. Okay, so the strobilus or the cone will form when the cone is formed. The fertile areas will alternate with the sterile region. Okay, because they look alike. You know the cones. I'm what to say, the fertile and the sterile one. So simply, because this is the same looking. Now let's say these are the same looking leaves. So if it has a sporangium, it means it's fertile. Then if it doesn't have, it means it's sterile. Okay, and they will alternate. Okay, so now let's look at the structure of the sporangium. Okay, so it was, remember the structure, it was round, it was like this, it was round. Then we had a layer of jacket cells. Okay, jacket cells, and then another layer of tapetum cells, and then inside were the spore mother cells. Okay, okay, so how they look, let's see. So the mature one, the fully grown sporangia, they are unilocular, means just single chamber. Okay, if I say bilocular, means double chamber. Tri will be three chambered. Okay, so when they are saying unilocular, means one chambered. Okay, one chamber. All right, so they are unilocular, subspherical, like this, not fully round but subspherical, and they have a kidney looking shape, reniform or kidney shape. Okay, the size of the sporangium varies from 1 to 2.5 millimeters in diameter, and the color ranges from yellow to orange. Okay, it has a short and a massive stalk. Okay, so if this is that leaf, no, that fertile sporophyll, no, this is the leaf, it's very short and big stalk is there, because it has to be thick, no, if it has to support such a bulbous structure like that. Thick and massive stalk. What is the color? It could be yellow or orange. And what is the size? 1 to 2.5 millimeter in diameter. Okay, this one, diameter, not length, diameter. Okay, let's go to the next. I think it's easy, no? Now comes to the little bit complicated, no, the development of the sporangium. Okay, how it develops. Let's look at the diagram first. If I turn my phone will be better. Yes. Okay, I hope you girls can see. Okay, so we started with an ordinary leaf. No, this is a leaf, ordinary leaf. No, because it's a microsporophyll. It's a sporophyll, it's a leaf. This is the axis, means it is the stem. No, this is the stem and this is the leaf. Okay, so we are starting with the leaf. Then certain cells, they behave as sporangial initials. Okay, now if you ask me, miss, how they know? It's not by me telling or you telling, it's in their genetic code. You know, they have evolved millions of years, they already have this program, this programming is already there in their genetics. Okay, like for example, some of you will have what to say, you'll be tall. So is the reason you are tall because somebody stretched you? No, your parents were tall, your grandparents were tall, your great grandparents were tall, and so on and so forth. No, it's in your genetics. Then some of you, your family is diabetic. So it's not because you eat so much sugar, kilos and kilos of sugar, that you got diabetes. No, it's in your genes. No. So similarly here, it's in their genetics, in their genes, and the gene will signal, give a signal to this cell and will tell, hey, you become the sporangial initial. You become also, and you also become a sporangial initial. So this sporangial initial, it could be any of these cells. Even this cell can happen. Okay, this cell also, if the gene says you become, it will become the sporangial initial. Even this one. All right, but it has to come from the leaf. Okay, so certain cells will behave as sporangial initial. Initial means to begin the formation of the sporangium. Okay, now next, what will it be? Let's go to number B. Oh no. 1 minute, girls. Okay, now let's look at number B. Now, what happened is that This sporangial, let me draw, is that brush or here? This, let's say this is that sporangial initial cell, okay? Now it will divide and there will be one here, one cell there and one cell below, okay? Now, wait, it's not dividing. This is your sporangial initial, okay? That cell in the A diagram, okay? Now the cell in this layer and this layer, they also will have some function, okay? You remember like this, the bulb was there was a layer of jacket cells. So like in this winter, no, it has, you have to wear jacket, right? You cannot just go in like t-shirt only, no, you have to protect yourself from the elements, no. So same here, these spores, spore mother cell, they have to be protected from the elements, so they has to form one jacket, okay, one jacket layer. So the function, you know, of the what to say, the work of the jacket, you know, the cells who will give rise to the jacket are taken up by these cells known as jacket initial. It is just above this what is that, sporangial initial, okay? So these jacket cells, they are not going to give rise to spore, no, they are going to give rise to the jacket, obviously, no, okay? It is it is these archaeosporal cells who will form the spores, okay? These archaeosporal cells, they have come about from here only, sporangial initials, okay? So let us read. Okay. Okay, so how it develops is it follows the eusporangiate type. Means this is the name, is a theory, okay? This is a theory called as eusporangiate, where they come out from superficial cells. Means remember that leaf, from the cells of the top of the leaf, okay, top. There is leptosporangiate type. There are so many different types, but here this type where the cell comes from the surface, right, is known as eusporangiate, okay? So here a single transverse row of, we'll go back to the diagram, of superficial cells at the upper surface of the sporophyll divides periclinally, okay? Okay, so we have that outer layer of cell, okay? This is the layer of cell. Then they will divide like this, periclinal, okay? Like this, okay? Up and down. So after it divided up and down, okay, when it divides from 1 like this, it divided, no, we got 2, right, 1 and 2. So then the outer one, the one that is still above, the outer one will form the walls, okay, will form the multi-layered wall, okay, means they will form the jacket in the future. And this cell, the inner one, it will form the sporogenous tissues, okay, like those spore initial, etc, etc, okay? So till here, I hope it's clear. One cell we had this sporangial initial, divide periclinally this way. We had two. This one will form the outer layers and this one will form the inner layers of sporogenous tissues. Very easy. It's not that tough. Okay. Then now remember, let's go back to the diagram. Okay, now, okay, here, see. First, we started with these sporangial initials. Then they divide this way, no, periclinally. And then we got one layer of cells which will form the jacket initial and the second, the other layer will form the archaeosporal cells. Okay, now let's look at the next diagram, that is C. Okay, so those archaeosporal cell, they will keep on dividing. Okay, wait, let me draw. We start with the sporangel. Oh, okay. Start with this sporangel initial, this way, like that, right? This is your archaeosporals. This is your jacket initial. I'll write J for jacket. Okay, JI, jack.